Square roots and other radicals are crucial in algebra because they help us find unknown values in equations involving squares and other exponents. They're also essential for solving problems related to areas, distances, and many other real-world situations. In case you're a little rusty with your perfect square roots, let's go ahead and review the first few of those. Let's start down the list a little bit here. The square root of 25, well, that equals 5 because 5 times 5 is 25. So the square root of a number is just asking you what number multiplied by itself equals the number inside the square root. So the square root of 1 equals 1, square root of 4 equals 2, square root of 9 equals 3, and the square root of 16 equals 4. Square root of 36 is 6, and so on. Now here we have a function with a square root in it, and we're going to evaluate that function when the input is 2. So the name of the function is g, and we're going to plug in 2 everywhere we see the letter b in the right-hand side. And the only math we're going to do is over here on the right-hand side. So g of 2 equals the square root of 7 times the input plus 2. So let's work out the arithmetic inside the square root sign. So we have 7 times 2 is 14, plus 2 is 16. And 16 is a perfect square root. It equals 4. So g of 2 equals 4. Now here we're going to evaluate another square root function, but this time in context. The height of a small dragon, in feet, t years after birth, is given by the function h of t equals the square root of t plus 3. What is the height of the small dragon, in feet, at t equals 13 years after birth? Round to 1 decimal place. All right, our input is 13, so we're going to substitute 13 for t in the right-hand side of that function. So h of 13 equals the square root of the input of 13 plus 3. Well, we go ahead and just add those numbers inside the square root sign and get 16. And the square root of 16 equals 4. All right, so the height of the dragon is 4 feet when the dragon is 13 years old. Now, sometimes we also encounter cube roots, and you can have fourth roots and fifth roots and so on. And a cube root is just asking us, well, what number multiplied by itself 3 times equals the number inside the radical? So let's start down the list here a little bit. The cube root of 27, or the third root of 27, well, that's going to equal 3, because 3 times 3 times 3 equals 27. All right, so the cube root of 1, well, that equals 1, because 1 times 1 times 1 equals 1. The cube root of 8 equals 2, because 2 times 2 times 2 equals 8. Cube root of 64 equals 4. And the cube root, or third root of 125, equals 5. All right, so here we're going to evaluate f of 4 when f of z equals the cube root of 4z plus 48. So we have an input of 4. So f of 4 equals 4 times the input, so 4 times 4, plus 48. Let's work out the math inside the radical sign. Right, 16 plus 48, that equals 64. And 64 is one of our perfect cube roots. The third root of 64 equals 4, because 4 times 4 times 4 equals 64. So f of 4 in this function f equals 4. So when the input is 4, the output is also 4, coincidentally. Okay, I hope these examples about evaluating with radicals have been helpful. This is Mr. Ela, signing off.